A very good morning to our distinguished guests, esteemed speakers, participants, and colleagues joining us from around the world. I am Dr. Smita S. Kumar, and I am honored to be your host for this special occasion. On the behalf of the organizing committee, it is my honor and privilege to welcome you all to the International Conference on Emerging Trends in Industry 4.0 Technologies held here at SIS Graduate School of Technology, Nerul, Navi Mumbai, and streamed globally for our international attendees. We are especially delighted to welcome our keynote speaker and technical experts from academia, industry, and research institutions. Your presence and participation make this gathering a true hub of innovation, collaboration, and knowledge sharing. The theme of our conference, Transformative Technologies for a Smart Tomorrow, highlights the urgency and opportunity in leveraging technical innovation to solve complex global challenges. We are especially honored to have with us Dr. M. Shashikumar, Executive Director of CDAC Mumbai, Shri Arun Ashan, Director, Softlink Global. We also welcome Shri M.V. Ram Narayan Sir, Vice President, SIS, Dr. K. Lakshmi Sudha, Principal, SIS Graduate School of Technology, Dr. Preeti Hemnani, SIS GST. To commence this auspicious event, I invite the dignitaries to join us for the ceremonial lighting of the lamp, symbolizing the light of knowledge and wisdom. I call upon our student, Ms. Janaki, for the prayer song. The prayer song will be followed by the Maharashtra Geet.
Jaya Jaya Swamin, Jaya Jaya, Jaya Jaya Jitavairi Vada Prachanda, Jaya Jaya Gajamuga, Jaya Vakratunda, Mushaka Vahana, Muni Janavanda, Dosharahita Durita Surabrinda, Sheshabhushana Shaiva Varidhi Chandra, Poshita Parijana, Pulnika Gandha, Jaya Jaya Swamin, Jaya Jaya, Jaya Jaya Swamin, Jaya Jaya.
Today, we are indeed privileged to have with us Dr. M. Shashikumar as our chief guest and Shri Arun Ashan as our guest of honor for today's function. I would like to take this opportunity to introduce Dr. M. Shashikumar. Sir is currently the Executive Director of CDAC Mumbai. His areas of interest are artificial intelligence and educational technology. He has co-authored 2 books, one published by Prentice Hall on parallel computing. He was a part of the KBCS Nodal Center at NCST, working on expert systems, resource scheduling, logic programming, genetic algorithms, etc. 12 students have completed their PhD under his able guidance. He has initiated and nurtured a number of projects in the area of AI and e-learning during his career. Sir has about 100 publications so far. He was adjunct faculty in the Department of Educational Technology, IIT Bombay, for about 10 years. He has also served as Director R&D at CDAC Corporate Office for 3 years. We are honored to have you with us, sir, today. I now request Ram Narayan, sir, to welcome our chief guest. Thank you, sir. We are privileged to have with us Shri Arun Ashan as our guest of honor. Sir is the Director of Softling Global, a leading provider of ERP solutions tailored for international logistics and supply chain industry. With over 25 years of experience in technology selling and logistics domain expertise, he has been instrumental in shaping software solutions that power top logistics enterprises across India and abroad. Sir is also a motivational speaker and blogger, an amateur theatre artist and short story writer. We are pleased to have you with us, sir, today. I now request our principal, Dr. K. Lakshmi Sudha, to welcome Shri Arun Ashan. Thank you, madam. We are honored to have with us Shri Faisal Khan, Vice President, Strategies Softling Global. I request Biju sir to welcome Faisal sir. Thank you, sir. I request Principal Madam to give the welcome address.
Respected Chief Guest, Dr. Shashikumar, Executive Director, CDAC. Guest of Honor, Sri Arun Ashan, Senior Director, Softling Global. Sri M.V. Ramanarayan, Vice President, SIS, Head of the Institutions, all the dignitaries, Conference Chair, Dr. Preeti Himnani, Vice Principal, Dr. Aparna Bannore, participants and my dear colleagues. On behalf of SIS Graduate School of Technology, I would like to welcome you all for the inaugural function of ICETI4T 2025 IEEE International Conference on Emerging Trends in Industry 4.0 Technologies. For the information of our guests today, the SIS stands for South Indian Education Society. SIS Graduate School of Technology, an integral part of this well-established community, started in the year 2002. We have 8 UG courses, namely Electronics and Telecommunication Engineering, Computer Engineering, Information Technology, Electronics and Computer Science, Artificial Intelligence and Machine Learning, Artificial Intelligence and Data Science, Computer Science and Engineering, and Mechanical Engineering. 2 PG courses in Artificial Intelligence and Data Science, Information Security. And also, we have 3 working professional UG engineering courses. The institute has been accredited with NAC A+. 3 of our courses that is computer engineering, electronics and telecommunication engineering, information technologies are accredited by NBA. We have received accreditation by Tata Consultancy Services and received recognition as TCS Priority College. We have received the autonomous status from the year 2024-25. SIS GST believes in overall development of the students and has been striving to provide holistic education. We always encourage our faculty members to upgrade their skills and also provide the platform to enhance the skills in emerging domains. We motivate the faculty and students for doing research, and our faculty and students publish papers in reputed journals, publish patents and copyrights. We have received consecutively 2 times funding from ICETI to organize Atal FDP on emerging domains. We give top priority on teaching learning. I am glad to inform that we have received Best Engineering College in Maharashtra for Teaching and Course Curriculum 2023 Award for outstanding and exemplary contribution towards education, skill development and research from Center for Education Growth and Research, New Delhi. We have also received the Industry Academia Community Excellence Award from Proud Councilage. Coming to today's conference, these 2 days conference will definitely provide the platform to learn upcoming technologies, advancements and current trends and research in emerging domains. Congratulations to all the organizing team for their tireless efforts to bring this event on board. Congratulations to all the participants and wish you all the best for your presentations. Thank you.
Thank you, madam. I now request Ram Narayan sir to address the gathering.
Good morning, everyone. Once again, a warm welcome to Dr. Shashi-Kumar, Arunji, Lakshmiji, Preetiji, all faculty members, members of the SIS, GST, and student friends. I am not the right man to give any address here in light of some of the experts sitting here. At best, I have been an user of IT for most of my professional career. Nevertheless, as Vice President of the Managing Council of SIS, it's my pleasure and honor to welcome you all to this very significant 2-day conference on the emerging technologies and its use in industry. I'm sure that at the end of these 2 days, all the participants and the presenters would be that much richer in terms of the wealth of knowledge. SIS would be hitting a century of its existence in 2032. Founded by middle-class South Indians newly migrated to the then Bombay, the values they cast in stone have been truly fundamental, guiding the society to what we are today. A very modest beginning with a high school in Matunga, catering to families with meager means. Today, SIS has transformed itself to a multi-located, multi-discipline-oriented, reputed education institution. Some of the latest babies in our fold are the School of Pharmacy, which we opened last year, and the SIS Incubation Center, which is housed in this campus. The Graduate School of Technology, which is hosting today's conference, is one example of the society's commitment to deliver the best in education to the vast number of students who will be instrumental in realizing our dream of Viksit Bharat in 2047. Today's theme will be focused on tech trends in industry. Rightly so. Education, especially in engineering and tech, should be impactful in shaping a better world. But technology is not just reshaping industry, it's also redefining the world of education to which we all belong. Perhaps generative AI has been a single most dominant theme in the last few years of tech changes. Even as I speak, newer tools powered by AI will shape how students engage and how teachers deliver education. But Gen AI is also just one piece of the emerging tech cake, if I may call it so. Equally revolutionary is data analytics and machine learning. We can, with data-driven insights, help identify learning gaps, tailor education to specific needs of students, and evolve leading platforms that can be productive in tracking knowledge absorption, performance, and optimize the resources. We can thereafter intervene, I think, with the use of technology. I'm not sure if intervene in a student's progress also. We can track how the student's progresses with these tools today. More significantly, I think all these emerging technologies are leveling the playing field like never before. Digitization in India has been hugely successful and has shown the light to the world for taking technology to the masses. The same impact is already felt in education. Access to knowledge and the quality of education will no longer be a limiting factor to a learner even in a remote village in the country. The same goes for healthcare, finance, agriculture, and trade. There are today, I'm sure you all know, there are YouTube factories in rural India which cater to a very huge, hungry, entertainment-seeking audience. So, these are exciting times to be in. I wish I was 50 years younger and be a student, like many of you. The challenges to harnessing these emerging technologies to deliver value in every field are many. There's a digital divide, ethical concerns. We are talking about plagiarism now, how we can track whether somebody has used AI to, including essays and stuff like that. There's a huge concern about data privacy, which is engaging all of us today. And like we were talking before his comments, technology cannot be a one-all solution, an all-be-all solution. Technology should not replace human connection, as it seems to be doing nowadays. But it has to enhance the quality of human connections. That is what tech can do. Today's conference, I'm sure, would lead to more collaboration, to more stimulating new ideas, and make us all realize our own true potential. Thank you, and once again, a very warm welcome to all of you.
Thank you, sir. I now request Dr. Preeti Himnani, the conference chair, to brief us about the 2 days international conference.
Thank you, Smriti ma'am. The future is not something we enter. The future is something we create. Said by Leonard Sweet. Good morning, everyone. Respected dignitaries, Dr. Sasikumar sir, Mr. Arun sir, Sri Ram M.V. Narayan sir, our principal Dr. Lakshmi Sudha, Vice Principal Dr. Aparna Banuri ma'am, faculty members, students, and dear participants. A very warm welcome to International Conference on Emerging Trends in Industry 4.0 Technologies hosted at SISGST. We are truly delighted to have you with us in these 2 days, June 6th and 7th, as we explore the latest innovations and transformative ideas shaping the future of Industry 4.0. Our theme, Transformative Technologies for a Smarter Tomorrow, could not be more timely. With rapid advancements in AI, IoT, automation, and other groundbreaking technologies, we are stepping into the era where smart systems are reshaping not just industries, but the very fabric of how we live, work, and connect. Let me take a moment to share the journey that brought this conference to the life. It all began 2.5 years ago when we first applied to IEEE Bombay section in around March 2023. We were thrilled to receive the approval by August 2023, and at that time the conference was planned in December 2024. So it was almost 2.5 years we first applied for IEEE conference, and this is our first IEEE conference of this institute. However, due to some issues with IEEE Bombay section, our conference was on hold for nearly 6 months. Then we faced with these challenges, we decided not to give up, and we reapplied, and this time through IEEE Interim Committee, starting fresh from again January 2024. The process involved several rounds of proposal revisions, discussions, refinements, and after months of dedicated efforts, we were pleased to receive final approval in August 2024. From there, we moved on building the conference brochure, website, then came the real learning curve, getting familiar with CMT platform, managing paper submissions, finalizing reviewers, coordinating the review process, and accepting the papers based on the detailed feedbacks. It involved so many committees, countless back and forth discussions, and a great deal of teamwork. Honestly, we have learned a lot along the way, not just about organizing a conference, but about collaboration, planning, and patience. We were thrilled to receive 461 paper submissions from across the globe. After a rigorous review process, 179 papers were accepted and 103 are going to be presented here in these 2 days. And that kind of response is a huge encouragement and shows the strong and growing interest in the field of Industry 4.0. This moment is also personally meaningful to me, as back in 2007, I had a privilege of serving as convener of the first ever national conference held at our college. And today, I stand before you as the chair of this institution's very first IEEE conference. It feels like coming full circle, and I'm filled with both gratitude and pride. I would like to sincerely thank the IEEE team, especially Dr. Sashikant Patil sir, for his unwavering support throughout this journey. A big thank you to our organizing committees, reviewers, volunteers, sponsors, and non-teaching team. Everyone who worked hard behind the scenes to make this event possible. Special thanks to my co-chairs, Professor Biju Balakrishnan and Professor Suvarna Chaure. It has been a pleasure working with you. Your support, coordination, and steady presence made this journey so much smoother. I'm also grateful to SIS management for trusting me with this responsibility. Special thanks to our advisor, sir, Dr. P.V. Parmeshwaran, our principal, our vice principal, and registrar ma'am, for their continuous support and encouragement throughout this journey. To all participants, whether you're presenting, attending, or just here to learn, I hope these 2 days are insightful, inspiring, and full of meaningful connections. Let's make this memorable experience for all of us. Coming together is a beginning. Staying together is a progress, and working together is a success, said by Henry Ford. Thank you, and let's get started with ICETI4T 2025. Thank you.
Thank you, madam. I now request the dignitaries on the dais to unveil the souvenir of our international conference. Thank you. I now request our guest of honor, Shri Arun Ashan sir, to share his thoughts with the gathering.
Good morning, everyone. Good morning to the dignitaries on the dais and to be the dignitaries tomorrow. What struck me was I remembered my theatre mentor. I mean, if he was here and if he had seen this gathering, he would have been very happy. Seeing the most brightest faces with the brightest of clothing, which is not matching with the background. See, in theatre, what happens is like, your clothing shouldn't match with the background. You should stand apart. So everyone here is looking so fab. A big applause to everyone. So, I mean, this is the way a day should begin, is I believe. Like, be it a professional, be it anyone in the teaching industry or students, you should dress up for the occasion. And an occasion happens every day. Okay, if the sun is up, then the sun is saying you, and the occasion is up. Dress up, welcome the day, is what and I'm so happy to be here. I don't, like, be it any engagements, I don't avoid or don't delay for any reason addressing an audience which has students in it. Okay. Because I always feel the age today you are, the students or the upcoming citizens of India, you are in the best age. Believe me, you are in the best age. To give you a context, okay, what you would understand, the age I was in. Okay. All of us like Hindi songs, right? All of us like Hindi songs. And in our days, Professor Viju would agree, Dr. Ravi Kumar would agree, we had cassettes. Okay. Anyone of you have seen cassettes? I can only ask you seen cassettes because you don't have the instrument to play. Okay. So everyone had their own choice of songs. Okay. So during my college years, we had to select these songs, put it on a paper, go to the nearest cassette seller, and he would record that songs. And we would get after 3 days. Okay, and then we used to go and collect that cassette and then come back. Okay, Walkman has yet to come, so we had to put it on your. Okay, come to 2025, what happens? Alexa, play Pasuri. This is what has changed. Okay, so you really don't know what age you are in, and you are in the best age. Okay, in terms of like where the country is. Okay. The best part, what has happened in the last 2 weeks, we are a very secure country also. Okay? Ghar pe घुस के मारेंगे. You understand? So you are we are a resilient country, but we will give it back. So you have to look at the larger picture. The larger picture is we are in a country where possibilities are, you can just run your imagination wild. Okay, run your imagination wild and make this country big. It is up to you. Okay, I'll just give you an example. There was this small company who used to sell dried fish and noodles. Okay. Today, this company's products, I guess most of us have used here, and this company contributes, mark my words, 23% to the country's GDP. 23% of that country's GDP. Okay. You are like anyone who would answer this without Googling, okay, I would ask the management to give them a prize. Anyone? Yeah, you are getting confused with the Maggie, right? They didn't sell Maggie to become 23% of the GDP. It is Samsung Electronics. Okay, Samsung Electronics is the only private company which contributes around 23% to the country's economy. they didn't stop at selling noodles or dried fish. They moved to conquer the electronics market, the consumer market. This is what a determination of a citizen of a country can do. You understood? A citizen of country can change. And believe me, South Korea and India got independence during the same time. Both of us are in our Amrit Kal. You understand? So what I was aiming at in addressing to you is, all of you sitting here, I was told by Dr. Biju, there would be around 120 odd students participating, 103 odd papers to be submitted. What I see is almost 120,000 jobs being created. Okay. None of you in the 10 years to come, like we are in 2025, you would be graduating in a few. I was told like most of you are in the 4th year or the last year. Okay, next 10 years, you should be creating jobs. You should be having your own companies, creating something which you see today is consumed or sold by not an Indian company. Whenever I walk into a big building, I'm just again throwing a trivia. I walk into a building, a high-rise building. When I see a Koni elevator or a Schindler elevator, I see why we are not there. Elevator बनाने के लिए इतना कुछ क्या लगता है यार? You understand? Elevator तो इंडिया में बन सकता है ना? So see, whenever you come out of your home, walk in anything, wherever you see there is a possibility of like where we can create stuff or our own. Okay, that is an opportunity. That is an opportunity. We are still using all those stuff what has been sent to us by MNCs. We are using Google. We have started using OpenAI. We have started using DeepSeek. We are starting to use them. That's good enough. But make your own stuff also. Okay, we shouldn't be stuck at innovating. Innovation is where, if I can speak about my company, we are a company into logistics, ERP, end-to-end ERP. We started almost 32 years back. We are the only company who started as a product company. Until then, the products used were, this is like close to 1995, 98, wherein Windows came in. We came in before Windows. How many of you know MS-DOS? Raise your hands. MS-DOS. Okay. MS-DOS was the first operating system where we started building applications. Okay, that is where we started building our applications for the logistics trade, particularly customs documentation. Okay. Still, the output was a piece of paper which got printed, because we were replacing typewriters then. Imagine we started replacing typewriters and calculators. And then we moved on to a Windows-based application. So whenever technologies came in, we were, I guess, one of the pioneer companies who took in technology beforehand. Today, we are a cloud platform spread across 52 countries. Roughly around 1.5 lakh users use our application across the logistics spectrum. But a purely India product. Before Make in India came in. Before the lion came in, the tiger was in. Okay. So what you have to look out for is the land gives you this opportunity to build your own stuff. And in India, people have built stuff, and which we have scaled like anything. How many of you have heard of a thing called India Stack? Have you heard of this word India Stack? Huh? Now, what is India Stack? India Stack is, you have heard of public infrastructure, right? Highways are our infrastructure, which is used by the public. Okay. MTNL was our public infrastructure or BSNL. There is something called digital public infrastructure. Can you name one? What is digital public infrastructure? Aadhaar is our digital public infrastructure. UPI is a digital public infrastructure. Now this is built by the government. Okay, this is built by the government. All the different applications or all the different innovations के लिए the government is creating the infrastructure. It is like working on this. Okay. One of the biggest creations from that infrastructure is something called ONDC. How many have heard of ONDC? Now these are the things what you have heard. ONGC, ONDC. Okay. Now ONDC is basically a network where you help buyers and consumers. अभी आप Flipkart, Amazon, Zepto वगैरह से जो माल मंगाते, they have their own infrastructure. Like imagine a small trader, if he has a stuff which he wants to sell, he can't create the entire infrastructure, right? So the country has created the infrastructure for them. So slowly the country is progressing for helping you guys to create what would have been costly. You understand? What would have been costly. So that has already been created. Imagine अगर Google Maps नहीं होता तो कुछ भी नहीं होता. Understand? There would have been no Flipkart, there would have been no Amazon, there would be no. So that is the baseline infrastructure. So these are the things what you have created. So nothing should be stopping you from creating your own entities. What I'm harping on is, I see Samsung, LG, Taiwanese semiconductor company in all of you. Okay, because you have to promise yourself you have something, and if you have been privileged to become an engineer, okay, it is a pledge to the country. You have to give it back to the country, because if you are privileged, there are still almost 10 odd students who were not privileged like you. They are on you to create their world. So that has to be your primary motto. And the individuals have created revolutions. How many of have you heard of V. Kurian? Have anyone heard of V. Kurian? Okay, anyone? I mean, like now what he has done. Have you heard of Amul? Amul is V. Kurian. If there was no V. Kurian, and he is not an industrialist. He was not an industrialist. He was a plain bureaucrat. Okay, what he solved is like milk getting waste. Okay, I would advise you to watch a movie called Manthan. Manthan is Dr. V. Kurian's story. Smita Patil, Girish Karnad. And this movie was the first crowd-funded movie. वहाँ के जितने मिल्क वर्कर्स थे आनंद के, उन लोग ने पैसे निकाल के ये मूवी बनाया था. And it was directed by Shyam Benegal, one of the. So the point is, how many have you heard of M.S. Swaminathan? Anyone heard of M.S. Swaminathan? If V. Kurian is known as the White Revolution, M.S. Swaminathan brought in Green Revolution. If we produce our own food, because the first 10-15 years, we used to import wheat from Russia. Imagine importing wheat from Russia. So M.S. Swaminathan is the guy who brought in the hybrid version of crops. Now these are guys who are not industrialists. These were inspiring individuals. You understand? These were, imagine the individuals who kind of wanted to give it back at a cost which, like, again, there were, like, these are Indian guys of big repute. You should be knowing about Jonas Silk. Anyone heard of Jonas Silk? He was a scientist because of whom polio is eradicated today. And this guy didn't make that vaccine patent nahi kiya, made it free. So these are the stuff what you should be working on and giving back. And the moment it hits you, like now you have an idea and you can do something to solve this. our country is in a position today to help you. Okay, you have to do your research. If you have an idea, each and every state government has an MSME with almost 75-80% of your entire project cost funded by the government, by state governments and central governments. So equip yourself in the first 10 years. Learn this art from the places you work and do whatever and start small is what I feel. Like there is a saying, I remember I kind of don't remember it now, but someone has said, yeah, in fact, Dr. Ravi Kumar, his small is beautiful. I remember your blog, sir, where you had written about small is beautiful. And never underestimate. This was like when I was reading his blog yesterday. He had written this so beautifully. So nothing is like you have to attempt big. You can start small, but start somewhere. And all the best wishes for your papers, what you would be submitting. And don't restrict yourself to the corners of this institution. The world is your stage. Thank you.
Thank you, sir. Before we proceed for the keynote session, I request our dignitaries to kindly occupy the front seats so that we can proceed with the keynote session by Dr. M. Shashi Kumar.
But so if the connection can be from there, that is good. If not, then somebody can always system. Is it audible? Am I audible? Anyway, I think I'll be audible even without this, so it doesn't matter. Okay. Yeah.
It is my honor and privilege to invite our esteemed chief guest, Dr. M. Shashikumar, to share a few words with us, followed by the keynote session on adapting emerging technologies for Industry 4.0, case study of AI. Over to you.
Okay. Sorry for little confusion there. I think it gave some people time to get out of the hall. So But I think that is okay. Uh, No. Okay. Yeah, so I think we are still in the morning. A very good morning to all of you. I think I have given a talk in the same hall a few years back, so it was nice to come back to the same hall. I presumably not the same people. So your event is basically on Industry 4.0. And then if you do Google or ask whatever Gen AI solution, what is Industry 4.0, it basically says everything that is newly being tried, you put it into the manufacturing or industry, it is Industry 4.0. But so it's actually a running definition. So we had the same thing we were doing for the last I don't know, 50 years, 100 years. From the time my manufacturing was there, industry has always tried to pick up whatever things is coming along and try to use it to improve its various aspects. Okay, I'll come back to that. And so my area particularly is I've been working in the area of AI, and like all of you, we are also getting very confused about what is Gen AI, whether we should do Gen AI or we should not do Gen AI and all that. So I will tell you a little bit of those aspects, but my involvement with AI is much earlier than most of you would be aware of. Well, I joined CDAC, or what was at that time called NCST, in 1987. Okay, so that I don't know how many of you were born at that time. So, so I came to NCST because I was interested in AI. So it is. We might think that AI is a very recent phenomena and all that things happening in the last 5 years. No. AI has been there for last 80 years, even older than me. Okay, and we did a lot of interesting work in that time in AI. So I want to look at AI from that bigger picture and not just take somebody's data, take some Keras or TensorFlow, put something, get some nice graph and say I have done my AI project. What is the project about? I don't know. Why? What is the data? I don't know. Why it is working? I don't know. Why it is not working? I don't know. So that is what typically AI projects are like. So I get a lot of students saying I want to do projects. I said, what do you want to do? I want to do AI. What do you want to do? No, anything AI. What is AI? That's it. That's end of the discussion, and the project also goes there. So anyway, so that is how the amount of hype that is going around the world, AI is taking the world as well as us. So let me kind of start with just a couple of slides on Industry 4.0. Again, I'm not going to give you a tutorial on it. I'm sure various people are going to talk about all that. So this is the definition which I picked up from one of the Google sites, saying integration of intelligent digital technologies into manufacturing and automation. So basically, it doesn't mean anything. It means whatever technologies are available, just use it. Okay. And just for examples, they say AI. Of course, you can't do anything. You are not even allowed to breathe today without AI. Okay. If you do anything without AI, you are considered old-fashioned, outdated, and possibly technologically backward or whatever. Right. So AI has to be there. And IoT, big data, analytics, cybersecurity, blockchain, robotics, and so on. So these are all buzzwords. And AI, of course, is the biggest buzzword that we all know. So incorporating current technologies and ideas to improve the manufacturing process. And so, to me, I don't think there is anything new here. Whatever technology comes, we need to adopt. So what is the focus, or why do you look at 4.0? You look at I don't know how much of this will be readable, but anyway, I can leave this. I just made this mind map yesterday. So if you look at this, the red square is Industry 4.0. Now, what are the typical concerns of an industry? Whatever. I mean, and you can even say we are also an industry. We take raw students and do various kinds of things on them and send them out into companies in one form or the other. So, and I can see the same similarity. You are actually kind of like a manufacturing industry. You're not manufacturing, you are kind of refurbishing, okay, like a car or whatever. But you look at industry, what are their problems? See, because what happens usually is that when you look at any of these buzzwords, like we used to talk about industry 3.0 till a few years back, you look at it from technology side. All these technologies I want to use. That is, to me, a silly way of looking at it. You look at what's your problem and say, okay, I have this problem which is still unresolved. What can the new technology do help me to solve that problem? That is how I look at this. So I always say, I mean, I tell the same thing to all this AI excited people also. Don't look at the technology. Look at your problem, the use case. I want to solve the, let's say, infectious disease problem. I want to do COVID management. I want to improve sanitation. I want to improve the environment. Whatever is your problem, whatever technology comes to help, use it. Who is saying that I should use only AI or I should use only IoT? The drive of what technology that you want to use should come from the use case. But that's not what happens. Now, if you look at all the papers that you're looking at also that we want to present, ask the same question. Whatever technology that your algorithm or whatever that you are bringing to bear on the problem, does it call for it? That's the first question that I would ask to any paper presenter or anybody who is talking about any solution. Does the technology that you are proposing to use, is it called for by the problem? So therefore, even when I say AI, I'll tell them that does your problem require AI? Not every problem in life doesn't require AI. Okay. Even as a human being, a lot of tasks that I do doesn't require brain. I mean, we do a lot of things as second nature, a lot of there are a lot of things which requires brain, your intelligence also. But there is a clear difference in the set. So, if I were to look at Industry 4.0 in my way, I'll say, okay, one problem could be the storage problem. Inventory is a problem in any industry. Okay, so you have your student inventory. Where do you keep them? And you had thousands of students who are not getting job. There also you have finished product inventory because you want to get them jobs and move out. You are happier, right? My finished products are all gone. So it's a good college, right? So in a company, it is the products that you produce and the raw material. If your process is very well planned, if your requirements are well understood, if your demand is understood well, and that is managed well, you will have almost no storage locally. That is what every industry wants. But it's not possible because you need to prepare for eventualities and some other things may happen and all that. So one of the problems that people might want to look at is, how do I reduce the amount of storage requirement? Or if I have to store, can I retain this material for a longer period without getting spoiled or without compromise? Now, ask the question, what technologies are relevant in solving this problem? I don't know. Is AI required there? Maybe in terms of better forecasting of the raw material or the product usage, yes. But that's a standard analytics problem. I think even simple statistics will actually tell you to do all that. Right? And another problem would be to efficiency. Okay. Every company wants to put 1 rupee and get 1,000 rupee in return in terms of money, right? Or 1 to million or whatever is the current scale. But efficiency can be in terms of the amount of monitoring and supervision that needs to be done. If the company will run on its own, I only have to come and maybe switch on in the morning. Ideally, even the switch on can be done by somebody. Then I'll be happy because no investment in human resources, monitoring, capacity, there are all that things. It just runs, right? But we won't do that because there are various aspects that will have to be monitored. So how can you improve the amount of or the energy that is spent in monitoring? The energy need not be only human energy, it can be other resources. You put a video camera, that is also money. There is also managing the that is required. You put sensors, that is also investment and to manage. So what can you do to improve the monitoring and supervision effort that is required in the industry? Now again, you can ask the same question. What technologies can I think of doing it? What are you monitoring? Where are you monitoring? Why are you monitoring? Then you say, okay, I can do that. I can bring sensors, I can do this. So in the olden days, when most of the things, everything was manually checked. You can check the pressure is okay, temperature is okay, this thing is okay. Today you put sensors, you sit in your control room and you get displays saying, yeah, the temperature is going okay, this is okay. You don't even have to do physically go there. Right? So that's how you build the technology to improve these things. Similarly, yield improvement and waste minimization. It's something that everybody wants to do. And even colleges wants to do all that. Right? Okay. Another aspect is quality improvement. If I'm not producing good quality output, obviously I'll have very little demand. I may not survive as an industry. What can I do? Given the raw material quality, get as better output as possible, and how to improve the raw material quality. These are all also quality aspects that is there. And maintenance. That is one place people are all doing so much work to almost do zero maintenance. How do I do zero maintenance? Preventive. I do things well ahead of before my car tire runs out. Within 6 months before I'll actually go and replace it. So I don't have any downtime. I'll get it done in 5 minutes time. Right. So similarly today again all these devices, whether it is your electronic devices from washing machine to so on, everything has loaded with sensors. So with all that data collected, you want to create models of when and how something will wear out or die out. That is good example for AI because there is good data, standard data to build models. But we don't know what are good maintenance models in all cases. Some of them we know, we look at periodic maintenance and all that. So maintenance is another area that any industry wants to look at. So you can take any of these problems and talk to an industry and say, what is your problem in this? Where are you currently? What is the desirable target? And then say, is there any technology which can I bring in to improve that? That's what all these games are all about. And we have also added this, I saw some link there, creativity. We want to look at newer ideas in the industry, right? So I want to look at new ideas, innovation, processes, all these things. Maybe I can look up, there is a new way of improving data quality, there is a new way of doing something else. So I can bring those processes and overall improve efficiency. It is not incremental improvement, I am actually significantly changing the process. So if you look at Industry 4.0, I would say, okay, these are my problems. Now you look at beyond this, sketch out all the technologies that you know and map it and say IoT would be good here. For example, to bring sensor integration, IoT would be good to do. But AI has nothing to do with that. Right? So look at it from that point of view, and then your approach to whether your research or publications would have more value because there is a use case there. I'm trying to solve that problem, and you are now here. Somebody can take it from there to there, and somebody can take it from there to. Okay, so that is the general advice as far as Industry 4.0 part is going. Okay, and as I said, it is not that industry has been sitting idle waiting for 4.0 to come to start working on this. They've always been doing it. Even AI, the AI that we used to work on, what are called expert systems, industrial robots, process automation, These have been there. Expert systems used to be a very hot topic during the 80s, 90s, last century, okay? 1980, 1990 period. It was a very hot topic, and lots of companies have invested a huge amount of money. Okay, I'll talk about it briefly when I talk about AI. And it was a very big improvement for many companies in improving product quality, the defect detection, and the maintenance planning. Okay, and a lot of other applications also. Similarly, industrial robots, not the humanoid talking dancing ones, but the ones who can do routine processes very accurately, have been around for long. It is not waiting for your current robotics. Now we are looking at little more fancier one who can also understand whether something is going wrong and be able to adapt to it. Okay, so these have always been there, and so often technologies are brought in not as per the use case, and that is where I find the problem. And the same problem I am finding with all these AI enthusiasts. Everybody wants to use AI, but they don't know what to do with it. They don't know what this AI actually looks like, whether it's a jackfruit or is it a mango, I don't know. But I have to have it with me, right? So that I mean, at least as academics, we should get out of that. We should have target-driven, objective-driven way to adopt these technologies. Okay. For any technology, proper understanding of its pros and cons is important to get benefits. Okay, and that's my advice to all of you, because as you are doing research and publications, keep that in mind. I mean, we have built a culture where when you present your paper, other than the session chair, nobody else will be there, right? And even if somebody else is there, he will not ask any question, so that you will not ask any question to the other person. So you don't get any feedback or constructive criticism from paper presentation. In the olden days, we used to go and attend sessions just to understand what is going on, just to listen to their perspective. So we used to ask questions. Why did you do that? How did you do that? But now I'm worried, because if I ask a question, then I might get asked the question. So it's better that we keep calm. Okay. So we have built a very sophisticated intelligence culture, and therefore our only option is self-monitoring. Okay, so with that background, let me talk a little bit about AI. Some of it might be familiar to some of you, particularly if you are teaching the traditional AI course. But I think what I want to tell in a way might actually still be interesting to you. Okay, so this part I've called it the hype and the reality, because for me, about 20 years back, it was more reality. There was very little hype. Nobody, I mean, of course, AI always had a problem, because it used to, people used to do a little bit of work and say, wow, this is going to change the world. And then you create a hype, and then you fall flat under the ground, and then you wake up again. So, no, I think something is still possible. You go up. So, this way we are used to in AI. In the AI parlance, it is called the AI winter that keeps coming in accordingly. And there are people who think that there is another winter coming for AI, where all the hype will die down, and people will say, no, I'm not working on AI, so don't ask. Okay. I hope it happens at some point in time. Okay. Now, why I like winter is it brings people to ground. Because otherwise you are all studying about the typical Bombay building height, 30 floors, stories high, you don't understand what is going on below. Okay, so the hype, today I feel there is possibly an equal amount of hype and reality, and it is very important for academia to understand that distinction. Why that hype is coming so much is also because the way these technologies are being pushed today. 20 years back, 30 years back, almost all technologies came from academia and moved slowly into industry after due testing, validation and all that, and say, this looks good, so they adopted. Now, it is coming from the industry and slowly getting into academia, and academia have no idea what is going on. You have to be, in the trendy, as somebody said, when I wear nice clothes, so I have to also I have to pretend that I know AI. So we are in that world. So, okay, so this is another mind map which I created some time back. So this is my view of AI. Okay, so this has a lot more stuff than what you would normally do. Again, it may not be very readable, and I will not go through all of this. So the top part of it here is what used to be the traditional AI. Okay, so and that's AI which I have also worked with for almost 20 years. And most of the bottom part is the current AI. So we almost start from machine learning, so the supervised learning, reinforcement learning, predictive models, deep learning, generative networks, adversarial networks, transformers, decision trees, and large language models, ChatGPT and friends. So all of these things. Okay, but all of these is now seems to have been forgotten. And I think colleges which are teaching AI, DS or ML course does teach that course, but I know there are no takers. Okay, nobody wants to do any project. I still find many of these areas very fascinating. I just 6 months back, I actually implemented a complete expo system shell, just my time pass. Okay, it is a fascinating area, but if I go and tell anybody, only Gen AI and you are whatever you want. Okay, tomorrow I think even matrimonies are going to be done by ChatGPT, Gen AI, than this is. We are getting to that part. I think somebody mentioned in the morning, we were also discussing, whatever you want to know, instead of going to Google, now you go to Gen AI. And unfortunately, Google at least, we didn't have too much of a trust problem because it was giving you a document link. So you read it, you look at where the document came from, who wrote the document. Then I even takes that away and say, oh, you have a cold. I think take some, whatever, XYZ. So you would trust it, you go and take XYZ and pay for it. Okay, so one point to keep is that we want to look at AI in this entire space. There are interesting reasons why we want to keep that space. Okay, so I'll come to some of these along the way. So what is AI that we were actually talking about? From solving simple algorithmic problems to mimicking the problem solving capacity of humans. So this, when in the 1950s, 60s, when the concept came and when Alan Turing proposed the Turing test and whether machines can become intelligent, this was the question. Because when computers came in, you had a different kind of machines than all the machines which were there till then. What was the difference? What is the difference between computers and all the other machines that we used to know? No storage. What's it?
User friendliness.
Programmability. So it is the same laptop. I can write games on it. I can do medical consultation on it. I can do programming on it. I can write documents on it. I can do all kinds of things in it. All I am doing is to change my program. You load MS Word, it becomes an editor. You load the spreadsheet, it becomes a spreadsheet manager. You load the PPT maker, it is a PowerPoint maker. Right? So the same machine without any change in hardware is able to mimic different functionalities to you by just changing the software. And that is something that people have never seen before. It was the first time you're looking at this kind of programmability in machines. Of course, CNC machines and all that with cards and all that were there, but they were too primitive to be called to excite people. And that meant that it was almost like people. We also do multiple things, right? So at home you are, you are a father or you are an uncle, you are a mummy or whatever, and here you are a teacher, here you are a student. We play all that different roles. You go to market, you are a completely different person there, right? Shouting at the shopkeeper, "Nahi, mujhe 10 rupees kam kar do," whatever. Okay, so the idea of going from simple calculations to building bigger abstractions was what drove AI in the beginning, right? So Of course, people are always trying to define what is AI, and then also we had a problem. Today also we have a problem. We don't know what is AI. The problem is not with the A, but with the I. I know what is artificial, but I don't know what is intelligence. We all think that we have a decent amount of intelligence. Okay, and while some of us might have disagreements about others' intelligence, but we all think that we are intelligent. But when do I say that this person is intelligent? I'm sure there will be 200 answers I'll get if I go and take a poll. Right? So, I'm also not going to attempt to define what is AI for the same reason. But there is a definition which we have found in, again, old definition. Machine shows intelligence if it solves problems that when a human solves, we consider it as an act of intelligence. So we are piggybacking on human beings. But this is also not a very clean definition because you may not know what is so intelligent about it. I mean, anybody could have done it. You also do that. But you get some sense, okay, you play chess, you don't expect that to be done, played by anybody, and you do very nice, very quick problem solving, very good at maths or analytics. So these are all things that we, at least by and large, accept as intelligence. So if a machine can bring that level of capability, we will say that since I'm saying you are intelligent because you are doing this, the machine isn't. Which is, but essentially what Turing also said, that if I can't distinguish between a human and a machine through some standard mechanism, I would assume that the machine is as good or as bad as the machine is, I mean the human is. So, unlike mechanical contraptions, we still do not understand human brain and its functioning. Okay, of course, for intelligence, the only role model or sample that we have is what is inside the skull. And frankly, we don't know much about it yet. Okay. We know a lot about it, but we still have so much more to know. We don't know how we learn, we don't know how we memorize, we don't know how the languages evolve, we don't know how we produce speech. We can answer some very top level thing, but beyond that we don't know. Particularly if you look at the human neuronal structure of the brain, from the neuron, how do we actually get the behavior? We have no idea. And that is the item we are trying to reproduce. Okay, so you can imagine why there is so much of confusion, there is so much of variations in what people are doing. So, on practical side, use computers to solve difficult but important problems. So, we are not, I mean, the ideal was like that, some intelligent tasks being done by machines, but this is okay. Though again, there are a lot of challenges in defining it. So, we will come back and say, if difficult problems which were difficult to solve at that time, could be done by the machine, it is a good AI application. So, people used to look at computer vision, for example, to be able to distinguish different types of images, to recognize your face. I don't know how many of you remember, when Facebook and all that came about 10-15 years back, you upload a photograph, it is just like a picture. It doesn't know whether it is a people in it or a picture in it. Today you upload a picture, it will say, this face is this friend of yours, shall I tag it? Face recognition was a dream problem 15 years back. Today, it is there on all your phones and everywhere that we don't even think there is any, we don't think there is any AI in it. But you think about it, how do you actually recognize a face? Right? If you, for example, let's say you take your mother's face or dad's face or your daughter's face or whatever, and you can do various kinds of changes in it, and most of the time you are still able to guess it. So your face inside a crowd, your face when side view, how are you able to remember all this? Do you store all these images? Do you store features? Do you store, answer is we don't know. But we do a very good job of it, that much we know. Right? Half of the Hindi films are dependent on that, right? So 30 years later, you suddenly say, Mama, whatever. So that much memory, and with the age change, you are still able to recognize and connect with. So, anyway, so we want to look at these kind of problems and recognize. So that is what we were slowly trying to do over a period of time. Lot of problems we have actually solved. As I said, face recognition, digit recognition, character recognition, handwriting recognition, information retrieval, to some extent even machine translation. These were all big problems. When I joined, we were also working on machine translation. Nobody in the world had an automatic translation. Google was hardly even existing at that time. Okay, so we also built some translation system. We are all trying to figure out how do people actually translate sentences. Okay, so these are all big problems, and with all these combination of technologies, we have some reasonable solution today. So we'll say, okay, this is some amount of some kind of AI that we are able to realize. So, what is an AI problem? A problem which characterized by some of these requirements, some of these characteristics, only then it is an AI problem. Okay, every problem that you think of doesn't actually fit into AI. There is really no need for an AI requirement to come in there. So some of these things are, for example, uncertainty in inputs and knowledge. This is actually key to human intelligence or all the intelligence activity that we are doing. Okay, so I'll take the standard example that I'll do. How are you going to go to your home or your wherever? Let's say at the end of the today's session, how are you planning to go home? I think you all have some plan in mind. You know, 214 bus will be right there. When I go there, at 5:14 that bus will come. I'll take that, go to the station. And when you get out, you find out that there is a huge waterlogging and there are no buses running. What do? You on the spot you replan. So you don't say, look, this is my algorithm, sorry it's not working, I'll stop, I'll sleep here. Some of you might do that. But you replan. So we have the plan. The uncertainty in inputs is sitting here, we have no idea what is happening in the world outside. We don't know whether the trains are being running, whether the trains have been permanently disabled, it will no longer run. I hope it doesn't happen. Okay, so all of these are potentially possible, but we are not even thinking about it. We have a plan, but we are able to adapt and replan. So this ability to handle uncertainty in inputs and uncertainty in knowledge is because most areas of decision making that we do not have full information. Right? The classic example is what the doctors do. No medical science knows enough about the human body to be able to justify that I'm giving you this medicine because I know you have this disease. They don't. There are some symptoms, some tests, something based on that they create a hypothesis. They most likely this is what it is because it is consistent with what I'm saying. Okay, if you have that disease, then this rashes will come, this pain will come. So maybe reverse calculation is what it is. But you can't tell if you go to the doctor and say, so look, medical science is incomplete, so sorry, I cannot treat you. Doctors will actually become more human and responsible, but apart from that, nobody will go to them. Right? So, dealing with that incompleteness, even in knowledge. Okay, I don't know all that. So what will I do? Based on the outer symptoms or whatever I am able to do, I'll give you something immediate, but I'll correct it tomorrow or day after, if you're still alive, when you come back. I might say, okay, get this test done, get this additional verification done, get this done, to give me more knowledge about whether my decision is correct or not. Right? This is actually key to a lot of human expertise. Like if you take your TV to the mechanic, you think he knows exactly what the problem is? For that he has to actually open up even the circuit board, which nobody will do. So again, based on symptoms, you make a hypothesis, like students answering exam questions. So laughing there. Okay. Yeah, I know. I've also done it. Okay. Incompleteness of information. You are taking decisions without knowing everything, but could have been known. But again, you adapt. Normal automaticity. Today you are told something, but half an hour later somebody says, no, actually that was false information. What it is. You don't, your system doesn't crash. You change your reasoning. Okay, I have decided that I am going to share car with my friend, but now no, trains are running, so I will go back to my friend. Right? So you are able to adapt your reasoning. And and the dynamic nature of inputs, something that we software people, I presume all of you are doing somewhere related to software or system building. When you actually write a program for a problem, your assumption is that the entire world is frozen till I actually write and test and put the program online. You drive a car, you're autonomous, and when some signal comes, hey, hold, freeze the world. Tell me, understand whether I should turn left or right. While you are deciding, the world has already moved. You already have possibly got a crash. You are possibly still not alive or whatever it is. So, dynamic nature of inputs. Now, if your inputs, why we are interested in AI is many of the problems which characterizes us, we have these problems. And we don't have any software solution which can handle it. Imagine writing a program, while the program is running, it modifies itself depending on what is happening outside. No, we don't. We take inputs at appropriate times, we will keep an eye on, but that's all. You can't redo or replan systems on the fly. We cannot, if I give some input to the system and then later I say, no, actually that input was wrong, can you change it? Decision taken and decision taken. You don't actually roll back or do all that. Actually, even we don't roll back. We move forward, but adapting that's a very hard problem. And that is why AI was very exciting. And if you look at even simple tasks, I'll come to that in a minute, addressing these is non-trivial. No algorithm approaches are able to do it. Okay, still today also we don't know. Okay, and that is why people are looking at different ways of solving problems. So, okay, this I think I'll skip. We have already talked about it. So, given these kinds of problems, is that okay? And there is one more interesting thing. We human beings have, at least most of the human beings have only one brain. With that brain only, we are solving all different kinds of problems. Okay, so we are kind of multi-problem solvers with the same resource. We are not even, in some sense, loading different programs to execute. Okay, so if I want to build an AI solution mechanism, that mechanism should also be able to be flexible enough that I can load different types of problems and it should work. I cannot have one machine built for solving one problem, another machine for another problem, etc. Okay, that is not AI, because human intelligence is like that. So therefore, we wanted to find out mechanisms which is sufficiently general that it can be adapted to any solution. And this is a very powerful notion, which again we are kind of ignoring in the current rush of AI. This is called a state space representation. Okay, and this actually is something that you will all understand when you look at it. Let's say you take playing a chess game. Even if you don't know the game, doesn't matter. There is an initial configuration, right? Initial board position where all the pieces are kept according to some rules. And then both sides will keep making moves. And what is the target? The player should win. Okay? Or at the most should be a draw. For me, the target is I should win. But for the game, the target is somebody should win or the game should end in a draw. Then the game doesn't go further. Now what happens in the game? In the current position, one of the parties will take one piece and make one movement. Then the other party does. So this you can say, this is my initial state. Party A makes particular movement, then party B does a movement, party A does a movement, B does a movement, A does a movement, B does a movement. So you can think of a huge tree hanging there with the initial state, and some stages I will say yes, you have won, or I have won, or the game is drawn. And most other cases will keep on continuing till the pieces remain on the board. Okay, so if you visualize that, what is problem solving now? You start from the start state, keep taking moves till you reach a goal state. Now this is easy to visualize when I talk about from a gameplay. Suppose you want to go from here to Pune. Your initial stage is you are in this fault. Okay. What are the things that you can do? You can get out here, you can go through this gate, go through that gate, go to this, whatever. Right? And from there you can take an auto, you can take a bus, you can walk down the station, you can take a taxi. Right? These are my some movements. Here it's a single player. Right? And the taxi can be taken to this place A, B, C, D, to the station, to the depot, to whatever. And from each of those places you can do further. Now, you in the room, you take all these moves, some particular point you will say, "Hey, I've reached Pune. My goal stage is reached." It's also a game, it's also a search string. Okay. Now you want to do a mathematical problem, right? Somebody gives you a problem and say, what is the value of x? You have a current state, which is all the given variables. The moves are the equations that you know, the substitutions, the simplifications. You do all that, and at some point in time, you will find that x equal to something. I reach my goal state. So, all problems that you know of, can be brought to this structure, that everything is a state space. And that was a brilliant generalization, because there is one model which is able to bring irrespective of the nature of problem. Therefore, now I don't care whether I'm implementing a chess game problem or a tic-tac-toe problem or planning problem. If it works there, it can also be applied here, because that's what I'm doing. Okay, so this state space search problem model is what was actually the initial major step towards solving these AI problems. So the AI system was something like that. So you are basically searching through this space, looking for a solution. What is the problem with this kind of a model? Think of a search space like that. Space can be huge. See, in 1950s and 60s, etc., you had possibly 1 megabyte storage, or and a few bits of RAM. What kind of problems can you solve with that? So there, the restrictions were too much. You could do very little there, but idea was good enough. So I said, okay, this can generalize. So that's why the first winter came, where people said, okay, now I can do chess, I can do Go, I can do all this because I understand the basic rules. But then you realize that the chess search space, the number of nodes in that search space is more than the number of sand particles in the universe. There is no way you are going to search a space like that and find the winning state. You need to be smarter than that. And what is the smartness that people do? You bring in knowledge. So you think, okay, so you talk, but although if you actually just look at the movements, it is some random movements of pieces on the board. But when you learn chess, you will say, no, there are strategies. I'll go to conquer the middle, capture this, I want to capture this thing, and then I'll use this. So you create a higher level strategies which are clusters of moves, so you get your search space becomes simplified. So knowledge becomes very important. And that is why so the old AI search techniques and knowledge representation was the key driving point. So you can actually find 20 years back also AI literature, full books devoted to this topic. The knowledge representation is so actually so much interesting. What kind of knowledge do we use? Okay, and that becomes another big challenge. Okay, so the knowledge representation typically people were using if-then rules, frames, semantic nets, graph structures, logic, and all that. The neural networks today, you can think of it as some kind of graph, not the kind of graph we were talking about, but there is some similarity there. Okay, so yeah. So what kind of structures do we use to capture knowledge? So people started proposing all kinds of things because this is the first time we are actually talking about how we are actually using knowledge to solve problems. We don't know. And we can't go inside. We know that we are able to remember, as I said, we remember faces. But we don't know whether there are these 4 neurons which actually captures your space. I don't know. It's all there. Even if I lose any particular, let's say 100 neurons, I'll still be able to recognize your face. Okay, so we call that holographic representations. So it is distributed, but where, how does it actually manage? We don't know. So people actually started proposing, and then these issues which I talked about earlier: uncertainty, plausibility, belief, non-monotonicity, special knowledge, and temporal knowledge. These, again, it looks so simple to us. Okay, so when you tell somebody, say in a conversation, I say, I met you in last December. Then you say, that was before I went to London. Yes, there was a wedding in California soon after that. You put these 3 pieces together and give me a temporal sequence. Right? So, this is something that we do very commonly. Talk to, listen to small conversations. You can see these events and they link together and say, then it must have been the time I was there in the college, no? I must have met you. Inference. All happening on temporal basis. Being able to know how are you able to capture this time reasoning? So we talk about interval arithmetic, we talk about time point arithmetic. Do we deal with time points or do we deal with intervals? There is a whole book on temporal logic, temporal reasoning, which actually talks about this. Well, there are so much of interdependencies, because now you go there, it is not only I met you before or after. So it is interval starting together, interval ending together, interval overlapping in the beginning, overlapping at the end. There are so many factors that actually comes in. So just dealing with the time, capturing that information itself became so complicated. So there are a lot of and similar issue with respect to space also. We have some spatial knowledge pre-wired into us. So we know, like when I'm looking at you, I'm only seeing a little part of your face, but I can visualize that there is a full person sitting there. That is my spatial representation, because I understand 3D, I understand, okay, there is occlusion, this part of it, so I say, no, that must be a person because I can see one eye there. This is the ability to deal with spatial knowledge. So each of these, and beliefs is even more complicated. Right? I think what he told you about the principal meeting, the vice principal was wrong. What do you understand? So it is, I think, is already one hypothetical world because you are not there in that world. And what he told is another world inside that. Okay, I wrote an event which is the third world inside. So these kind of nested worlds, we are able to keep track of these worlds, and still you can go and tell, no, but I don't think, whatever, the trustee knows about it. Right? So you bring that fellow into that inside world of these beliefs. So this is actually what human knowledge processing mechanism is. And that is what we are saying that AI we will replicate it. And that is why I am saying Gen AI is nowhere getting to that, because this is the level of analysis or capturing which we have not experimented much. So there is still a lot of open AI is there, not open AI company, but open AI. So, okay, some of you might be familiar with this microphone. There was an experiment. So, okay, so people understood that there is a lot of knowledge pieces that we bring in, we acquire, we pre-wired, whatever it is. So for a normal, just simple behavior of people, somebody has to navigate these stairs and go out. What is the kind of knowledge that is required? Okay, one is of course your leg movements, etc. But you have to adapt, right? There are obstacles. If you find a person standing there, you say, "Excuse me, you want to there." But if you have a chair there, you don't tell, "Excuse, please move out." You don't. You actually move. Either you take the thing or you move the chair. Your behavior changes, your plan changes, right? So there was one study was, you take something like a 4-year-old child. How many these kind of common sense information do you think a child like that would have? At birth, I mean, there is some pre-wired thing, but nothing more than that. In about 4 years' time, how much of common sense information does a child acquire? Anyone want to guess? Huh?
90% further required in life.
No. How many pieces are there? Suppose I want to mimic the behavior of a 4-year-old child. How much information will I need to capture? I mean, I'll tell you what kind of things. So, if I keep it like this, you will not be very worried about it, right? But if I do like this and I'm about to leave my hand, you will actually jump up and there it is. It will fall. A child also knows that at some level, if it drops, it will break, should not do. Other places, it is okay to keep. Where does all this knowledge come from? This is what we are calling as common sense knowledge. There is also a lot of, I mean, so much of people say that study. Like, for example, if somebody goes from here, if it is a normal situation, you go from there, a very small child, 2-year-old, 3-year-old child, somebody goes from there, he'll actually turn there to look for him to come out from there. Special reasoning. To know there is continuity there. He will not disappear into thin air, unless of course he knows that there is an exit there and etc. But small child may not know. So if something disappears, it is expected to continue that till it reappears. So there is a lot of this kind of things. The observation was that a 4-year-old child captures something like 3 million facts by the time he is 3 years old, 3 or 4 years old. So I need to capture all this. Now a lot of it, when you think about it, doesn't even look sensible to you. Okay. So for example, if I take a piece of paper and then tear it, both remains as pieces of paper. But if I take a glass and break it, they don't remain as glass. I mean, they are glass pieces at most. Right? You take a wood and cut it, they are wood pieces. So, what are composites which are divisible, breakable, non-breakable? I can't take a block of water and cut it, for example. So look at the amount of things that you know by the time you are just 4 or 5 years old. Okay, and that is what is actually driving you so that you are still comfortably walking around without falling and not hurting yourself. So there is an experiment to capture all these common sense knowledge onto a computer. That is a famous experiment called the CYC. CYC is short form for encyclopedia. Children's encyclopedia, the knowledge that you wanted to do. But that experiment actually failed. After about 10 or 15 years of funding and research, didn't get anywhere because the kind of world model that you have in your head, you still don't understand that. So you think of something like you start with different things. Now what is the classification there? Right? And what are the properties there? So when you go from a parent to a child, some properties are inherited, some properties are not inherited. Right? So there's so much of knowledge pieces that we know. And it is not statistical or whatever. This is knowledge that we know. So that is kind of thing that we were, I mean, why the real AI actually gets to be so complicated. Okay, so that's where, anyway, machine learning also came in saying, well, I can't feed all this, compile all this information and feed it into the machine is not possible. If a human child can acquire as much information as it needs for it to grow and do things, let the machine also acquire. That is what machine learning is all about. Okay, so again, a lot of work happened in the area of machine learning. So in the space of knowledge, there was one interesting thing that was noticeable there. It is relevant to your current AI. We were actually, because the way we were looking at that problem, the search techniques and the knowledge to manipulate the search, the knowledge remained separate from your core algorithm. Right? Because they were things which I used to manipulate. I told you, the algorithm has to be general. Well, I cannot have one brain for doing one thing, another brain for doing something. It's the same brain which is going to take, and the same eye which is going to take inputs for all kinds of things. So, the algorithm has to be general, but it should be customizable depending on different types of problems. So, that knowledge was basically that customization engine. But, so because of that, the knowledge was kept separate from your algorithm. So, such techniques were different, knowledge was separate. And because these knowledge were, not available from anywhere, particularly in those days, there is no data available because there is no digitization, there are no computers, there is no internet, there is nothing there. The knowledge was acquired from people. You talk to the person, acquire the rules and whatever that is required. So, this knowledge had to be kept in a form that is visible to the or understandable to the human person also. Because I can show him, see, this is the rule that you told me. Is that okay? So this separation was very important. And what did that give you? It made sure that the knowledge was visible, unlike your AI today. So if when your Gen AI or your deep learning says that, okay, you have this disease, don't ask. If you say you have the disease, you either believe it or you don't believe it. That's it. You won't go back and ask what made you think so. Why did you say so? But I don't have this symptom, but you still are saying this. I won't do all that. That capability was there before because of this ability to keep them separate. So this allowed the knowledge to be examined by experts independent of the running system. The rule is not sounding right, this relation is not valid, and so on. Okay, so the knowledge was, the simple types of knowledge that we were using was like that. If symptom is fever and duration is greater than 3 days and fluctuation is present, then suspect this disease. Our hypothesis was that doctors actually use this kind of knowledge. This is what they learn in their, with experience and also in their college days. Okay, so, and you also have knowledge like belt is a type of furniture, crow is a type of bird, all of this kind of thing. That's a semantic network, this one is the rules. With these rules, people are able to actually build problem solving engines. And that's what I earlier mentioned about expert systems field. And when I use that kind of system with those rules as the core, I can actually ask the question, why are you asking me this question? Like when a doctor says, whatever, some little personal question, do you have this problem or this problem? Why you want to know? So the doctor has to give you an answer saying, look, this problem that you are reporting, it could also be due to this, and in order to rule that out, I need to know this information. That is the reasoning. And I can do that with these rules. So it will tell you that, look, I am currently using rule R4, and for that rule, I need this parameter. That's my master. Does this make sense? You can be, you may not agree with it, but that's the rule, it is there. So you can go and update it there. And similarly, you can tell that, how did you conclude that I have this disease? It says, look, I use the rule R14. R14 is like this. So you can see, okay, all these conditions I have. So, okay, the system's decision is not arguable. maybe that rule is incorrect. Then I would go back to the doctor and say, no, I think there's a problem with the rule. You correct the rule. So these errors and reasoning was becoming more useful. That was one great advantage. So this explainable AI that most of you might be watching what I'm talking about was already there. We were able to explain most of the things in a reasonable form using this kind of models. Okay, so it's not very nice English like your ChatGPT does, but it conveys the facts crisply and cleanly. Doctors can understand, persons can understand. Okay, and it's also useful to know when there are problems in the system which need to be corrected and all that. Okay, and then we are in the current age of deep learning and all that, and all associated issues. So we are actually talking about so where is the knowledge sitting in the deep learning system? In the expert systems, I told you, those rules is my input. I actually put those rules. I can actually edit the rules, and the system will behave. But in deep learning system, all that knowledge is sitting in some 1 billion numbers. I don't know what the numbers mean. I don't know whether individually those numbers are right or wrong. There is no baseline for anyone to check this. So a connection with the weight 0.4, I don't know what it means. But I know that if I change that 0.4 to 0.3, the error rate might go up. But why? I don't know. So, and if you look at all those 1 billion deep network nodes, I don't know what the nodes represent either. Okay. That is possibly okay because if you go to open your brain and pick up some few neurons and say, what does the neuron do? We also don't know. I mean, our behavior is also more holographic in that sense. But, so, this visibility of knowledge became a challenge because knowledge was no longer visible. It is all hidden. If you trust the output, well and good. If you don't trust, God save you. Okay. And that is actually where we are. These are black box models. If the answer is required, if only the answer is required, is fine. Otherwise, you cannot do any check. So trust building is very difficult. And that is why we also talk about trustable AI and those aspects in AI. And we have a lot of data. So that is what we are now trying to rely on. But we are going to the extreme, saying that everything can be done from data. Now, if you have a model, you write a program, right? Some sophisticated program which takes some inputs and produces some outputs. Now, suppose you run this program for a variety of inputs and store the input and output. Is that equivalent to the program? Can I now throw away the program and say, well, I have done it for enough number of inputs and outputs. Now I don't need to the original program. That is something what we are trying to do. We are saying that we have enough data. Now, in the extreme situation where every possible combination has been tried and stored, you can do because whatever combination you want to check, it is there in the data set. But that is also not possible. You cannot cover every possible way, for example, an MRI scan will look like, or every possible patient information, every possible, this is not possible to cover. So there will always be gaps. And then we don't know whether for those gaps will be filled by statistical, extrapolation, interpolation, or whatever, or what other variables will be going to do. So people talk about synthetic data generation and all of that. But there is also the problem, which is something that maybe some of you might be looking at also, data vulnerability. Because the entire knowledge in an invisible form is there in the data set. If somebody for some reason goes and tampers with the data set, you are not going to know. The reason, one of the reasons being that it's millions of entries, no human being is going to look at the data. So if the data gets tampered for security reasons or my intentionally or otherwise, your system will produce output because there is no question of neural network failing to produce an output. It will always produce an output. Whether that is right or wrong is somebody else has to decide. And there is no gold standard. Right? Because Your data is your gold standard. If that data is tampered, then you have no idea to know whether you're getting financial plans or not. And that is one reason why a lot of deep learning systems have been pulled out of after deployment, because suddenly surprises come in and you get behaviors which you never anticipated. Okay. And remember, the system has no way to validate data. It is purely data driven. So whatever you say, right? The common example I give is that if you take the data and let's say some 100 or 1000 males, you set the pregnancy flag to yes, it will go with it. No. Now what tells the system that men cannot be pregnant? It is not statistical data. So when I do the knowledge intensive part of it, at least there is common sense knowledge to say that look, there is a problem here. How can this be? So the system can actually ask that question. But to ask that question, I need a gold standard, I need a common framework, which is not there. Okay, so that's why we are asking about explainable AI. Saying, can you explain the performance? Which we is not able to do. People are talking about all kinds of things, saying yes, I mean we will give you that weight, we'll give you a scenario analysis, but that is not explanation. Explanation has to be symbolic tense as to what has caused, why did I look at this factor, why did I ignore something, how did I come to the conclusion, which requires reasoning capability. Okay. So how can you produce explanation capability in deep learning based systems? And when you do things like convoluted neural network or recurrent neural network, the problem is even more challenging. Because the usual network, you have input, it just flows all the way to output. Now in convolution, there are internal transformations that's happening. So depending on what point in time I'm looking at the weight, the weight would change. Right? And recurrent actually feeds the output back into the input. So that makes it even more difficult for me to use the weights as an explanation. So there is an interesting book by David Kahneman called Thinking Fast and Slow. So he has a similar problem with the human brain also. But we don't really know how human brain is able to do it. So the belief is that our brain also has something called system 1 and system 2. The what is called the spontaneous or the autonomous part of it, and the reasoning part of it. So if you walk up there and suddenly you slip, you will immediately step back or you take a corrective action, which is not a thoughtful action. It is just naturally happens. If you slip something, you will immediately step back or, and then you look at it. Achha, it was plastic paper. Move it and then your system 2 is in action now. It figures out why did they slip, but there was no other problem. What would happen? And all the corrective actions happens with system 2. Okay. So system 2 is able to provide explanation, to understand, to generate all these variations and all that. System 1 is like your deep neural network. But the challenge is we don't know why and how our system 2 is able to get the explanations and all that from system 1. How is it connected? Because our system 1 is also neural network. Okay, what is our system 2? Where is that explanation capability coming from? We don't know. But we know we are able to do that. Okay, so I'll wind up now. Okay, so this explainable AI is something that people are very seriously looking at. I hope some of you will also explore this topic there. And another topic that everyone is talking about is AGI, artificial general intelligence. Now, in the earlier AI, there was no AGI because our AI was AGI. We had nothing called special intelligence. It was all supposed to be general intelligence. But now our AI is actually special intelligence. Therefore, now we want to generalize. So if I have a system which recognizes a space, I also want it to be able to do classroom planning or to do some other purpose. I have to generalize. How do I generalize? Your neural network weights cannot be multi-purpose, right? So that is what the people are doing. So it says, as long as you are getting to a single task activity, you cannot call it intelligence. You are a specialized machine. Okay, so that is the challenge here. Okay, and of course, Gen AI, everybody's excitement. So the point about Gen AI that you want to remember is that I mean, of course, mostly it is based on LLM, large language models. But what is LLM? It's a probability model. So if you have your mobile phones, when you type something, you type one word, it will give you a possible suggestion for the next word. That is all that your LLM does. Except, it's not one word, it is about 100,000 words before is looked at your context to predict the next word. But your phone is doing it with one word. And of course, phone is more often erroneous because one word is barely enough to do that. But there's the same concept that Gen AI is actually doing. Now you can go inside and understand what are the problems that comes with it. Okay, so the entire Gen AI answers video or tape, whatever it is all a sequence of predictions. So you give your prompt and I start expanding that prompt one word or one token at a time. And that's what it does. And just repeat the cycle. Since the context is so big, and there is a very smart engine behind it to store all the probabilities and all that, you are able to get what looks like a good output. Because English errors will be very less because grammar will be taken care of by the large context. Okay, so but the important point is to note is this is only a feasible candidate. There is nothing called right and wrong in Gen AI. Because it's a probability prediction. Given this prompt, what is the next word which is most appropriate? So it gives you that. Nobody is saying what is the next correct word. Oh, there is no baseline. I don't know what you are talking about, right? I'm trying to write something for you. So there is no base correctness. It is only most appropriate, most likely, and most feasible word that is getting filled. To the extent that filled word might even be, can be fully wrong. At least in many cases, it can be wrong. Okay, and that's what gives you hallucinations. Right? I'm not sure you would have heard about it. The hallucination comes because the machine is creating things which didn't exist because the machine has no expectation of checking with reality. What probabilistically implies is just being followed. I don't know, for example, what is the, if you do a citation, okay, your all publishing papers, citation is what? You put an open bracket, close bracket, an author name, one or more author name, and a year. I can generate 3 names and put a year and get a citation, no? Oh, who ensures that there is a paper written by this fellow published in a platform which is acknowledged there? So there was, I think last month or something, there was a case where a High Court judgment cited 2 other judgments from Supreme Court or something, and based on which the judgment was implemented. And it turned out those 2 judgments, everything that was not done. There was no such judgment. But it's a citation, so you can produce it. So this is the biggest danger with the Gen AI solution that is to be done. Okay, whether it's students doing it, particularly if your output is a serious matter, because there may be a lot of factual errors that can come. So, not much understanding still of, and one of the things that I would actually want some of you to take up is to study and understand how Gen AI works. How Gen AI works meaning I don't want the formula that is available on online. Study the behavior, because today systems like Gen AI, what it is able to do is surprising the people who built it also. Because they never thought this is going to happen. So this is what is called emergent behavior. It is like the bird flocking, you see the flock of birds which are flying. You think they are coordinated so nicely. There's a radio communication. Hey, you come to the center, you are moving off. Nothing. They don't even know they are flying together as a group. They don't know how many people are in the group. They have some simple rules to follow. But it looks like there is actually a leader which is actually controlling. They all fly together, and in most cases they all reach their destination thousands of miles away. This is what is called emergent behavior. And Gen AI is also an emergent behavior. But it could be good to somebody to evaluate it, study under various types of prompts and queries and all that, find out which works, which doesn't work, go deeper, and find out why some things are not working and why some things are working. What are the boundaries? This is something that we have not yet done. We are all riding the wave, right? Then AI is helping us, we just ride along, but we are not understanding the tool that we are actually using. And for an academic, that is not a good sign. Because we are all supposed to query and probe and deep and sit on things which we know very well. That is no longer true with Gen AI. So simple option, these are not matching, the system is set to hallucinate. And hallucination is a big problem. Okay, and the last point is also very important. I touched on it earlier that the entire thing is being built out of data. Who is verifying the quality of the data? Nobody. Okay, even in Gen AI, you are taking the entire web data. Right. Statistically, presumably, you are getting it right, like Wikipedia. Nobody is guaranteeing correctness, but it is highly correct. So we can believe that statistically most things may be right, but there is no verification of the data that is driving it. And the data problem can be this huge entity called bias. There's an ICETIM paper you can look at. So, from sampling bias to measurement bias, labeling bias, negative set bias, framing bias, sample selection bias, all of these are major concerns. It is not just on your data. Your algorithm usually has built-in biases, which we don't realize. But there are cases where the algorithms have been. So people are asking for algorithm audits to make sure that biases are not creeping into it. These are also huge challenges. Most of the time, again, we don't notice it because you want to write an essay. Looks nice, so send it off, right? You don't realize the racial discrimination, gender bias, and all that creeps into the output because of the data and the algorithm bias. So this is another big worry that need to be looked at. So this is for you. We need research on all these cases. What is the real capability of an LLM or even Gen AI, and where it will work, and what are the assumptions for use of any of these technologies. So these are things that you should keep in mind when you are looking at your work. Okay, so I think I'll end here. So obviously AI is very exciting. So as I said, I was excited about it in 1987, and I'm still excited about it. So there is interesting thing there, but it is a much bigger, much broader umbrella. There are so many different aspects because AI is, as somebody said, the brain is only 5% of your body weight, but without that 5%, the 95% is useless. Okay, so that 5%, but you don't understand also. Okay? But so therefore, and that 5% is not tailored to only one task. From your communication to daily operations to planning to everything is controlled and activated by that. Okay. So we don't know what is the kind of structure it uses, how it works. So there are cognitive science, psychology, genetics, all of these are relevant areas for AI people to look at. And so there is a lot in the kit to address practical challenging problems, but ensure that you understand the foundations well so that you don't get into pitfalls. So thank you for your attention. It's long. I'm getting tired. Important area of concern and potential, but do with caution. And okay, that is my email address. can get in touch. So thank you. Yeah, I think we can take it.
Thank you, sir, for this insightful session on artificial intelligence. I now request our Vice Principal, Dr. Aparna Banore, Madam, to deliver the vote of thanks.
Before that,
Yes.
Yeah.
in fact,
Huh?
I had a few meetings. I end up and asked Faisal to cancel because this was the best live podcast, I would say. On AI, I would have because I'm a big consumer of AI related stuff, and I keep track of and whatever. For the first time, I would have understood hallucinations. So hallucination was one thing which I really understood. Bias is one thing which I have experienced also, because I don't know if anyone here has used a DeepSeek. Who has used DeepSeek? Go on today and check if DeepSeek answers Arunachal Pradesh. It crashes. Okay, it crashes. So what Sir was explaining on bias was we really don't know. And the other part, what Sir mentioned on the racial bias. Try to write a story. Okay, racial biases coming if you don't explain the character story. So that part I have this kind of a very well explained podcast. I'm sure it has been recorded. This should be on your.
Yes, sir, it's been recorded.
And the questions I wanted to ask you was, tomorrow do you see AI tracking consciousness?
Oh, actually,
We could be getting there where tomorrow if you shouted Alexa, Alexa play this song, Alexa would tell you, don't shout at me, I have emotions. Understand? So this is what AI is getting at. So I was just wanted to ask you, sir, are we near there? How far are we?
I actually noted down that point somewhere. I thought I should touch on it. No, I don't have an answer to that question. For the reason that, if you don't understand intelligence, we understand even less of what is consciousness. I don't know. I sometimes wonder whether I am conscious or unconscious. But there are some interesting things people are talking about. Quantum and consciousness, people are seeing a lot of connection. Because, if you see all the old mythology and all that, people doing time travel faster than the speed of light, and people being simultaneously present at multiple places, all over cities and all that. We think it's all imaginary situation, but that's exactly what quantum does. So he says, if that is, if this is possible, and quantum is feasible today. We don't have realized the systems yet, but the concept is very similar. So as we unravel more of this, they are saying that maybe that chapter about consciousness might also be addressed in that process. I'm not making any claim per se, but this is something that I read, and it intrigued me because as computer science people, consciousness is completely out of syllabus. We don't want that to be discussed. But suddenly, the whole thing is actually walking into the classroom because quantum is very much there for everybody. People are all talking about quantum technologies and how that happens, etc. But the other aspect of quantum is this, the quantum physics and those kind of this, right? So if that picture emerges, maybe there is an answer to that. There is a book which I am currently reading by Ray Kurzweil. He is a AI philosopher character. So the recent book is called not linearity, what is it called? I think super conscious. Is it nearer? So this point is, that word is escaping me. This point is, there is a point at which human intelligence and machine intelligence is going to come on par. We are almost there. If you look at least 99% of the people, they don't do anything more than what Gen AI does. I'm not meaning to do meaning, but you ask a question, Gen AI gives me better answers than what most people will be able to do. There are very few people who do. And even IT people who do programming, 90% of them don't do any serious programming. It's only drag and drop and copy paste, which Gen AI can do very well. And that is the jobs which also people are saying is at stake. So there is a big chunk which he claims we have reached. Now what is the future ahead? If you look at from that point of view, coexistence, one of them taking over the other, or other kinds of tussle that's happening. One point he is talking about is the entire digital space being an extension of our cognitive space. I'm not talking about you going and picking a pen drive and picking a file. The pen drive is accessed in my brain. Cloud storage as an extension of my brain storage capability. I mean, intriguing thoughts. I don't know whether to believe or whether to do anything, but all these are being talked about. We have to wait and watch. I think you said we are living in the best era or whatever. I think the vice principal said. But yes, it is a very challenging era. We don't know tomorrow will be what news will bring. But these are all interesting things. And we are also getting insights into our own thing. I mean, one of the reasons why I was excited about AI is also because it tells you about human intelligence. The cognitive science was using AI to explore human intelligence and at the same time using those ideas to solve practical problems. All these are interconnected. It's a fascinating area, yes. I'm not answering the question, but yes, that's what all these things are being discussed.
I have one question. Since you said that hallucination, there are a lot of, documents that we have. What is the current status of governance in AI? Are we having any mechanisms to figure out whether the data is correct or what we're getting as an output? Is there any progress on that? Because surely we can't leave it unattended, right? So there must be something going on to govern, to ensure, security of data as well as the output.
See, I don't think there is a unique or final answer to that. It is something that is concerning all the governments, all the public, everybody. Because also remember that unlike the data analytics data, what AI is using is much more finer grain data because we are trying to do behavior tracking. Okay, which is obviously your personal data. But now it is that which is actually powering all the writing that you do. Somebody would have written something about you. I don't know whether there is a problem there is something good or not. Who is going to check all that? The trillions of bytes of data that is sitting on the net is nobody is going to investigate it. It's not possible. You only going to get another AI program possibly to look at that data, which is obviously not reliable. So the concerns, I know also talked about bias in the data set. So people download some data and do classifications. So for example, a lot of studies which says that the downloaded face recognition data set behave badly for Indian faces because we are called colored faces versus that. Similarly, there are cases where the African kind of thing because that different population. So all kinds of things where what your data set is not capturing is not applicable to the testing data set, you can get any junk output. Now, if you were to run a normal program, your system will say, sorry, my program is not designed to capture. AI program will never say this. Because a face is just an image. And so, I also say that if you, let's say you give a lot of male and female faces, and tag it, and you want to know which is male and which is female. Job, done. Now suppose I put this glass. What do you think would happen? It will make it either a female or a female. Because it doesn't know anything else. If the male number is little higher than female number, it will say this is a male. Now you can sit and argue whether glass is male or female. So the limits are very, very shallow. The concerns are there. But there is no, I mean, you can pass a law saying that everybody should use proper data. How do you guarantee it? How do you ensure it? How do you put a check whether I am using proper data? Nobody knows. Particularly in most of the problems that you deal with or programs that you deal with, your data is very small. Even if you talk about big data, it is like few megabytes or whatever data. Here we are talking about literally whatever terabytes and exabytes of data. There is no way anybody is going to validate it. If you suspect that the 1 millionth, the 42nd row has a problem, you can go and tell the court will look it up. Yes, there is a problem. How am I supposed to find it? So these are big questions, but the concerns are there. People are trying to look at it. What is the solution? I don't know. Some level, legal sanctity. There are also top level people are, jumping in and walking out of Google and all that is one part of it. Thinking that this is going in an uncomfortable direction. But who can stop it? So your concerns are well noted, but I don't know what the answer is. Everybody is concerned. People are trying to pass laws and put rules and all that, but law is not a solution. I mean, there are so many laws which say you should not steal, you should not murder, you should not do. But how many murders happen in the country? So law is not a solution. We need something underground, on the ground to ensure that it is doable. That's that.
Any other questions? Thank you, sir, once again for the interactive session. Over to you, ma'am.
We have been listening to you, sir, from now.
I know.
So let's enjoy the session. Warm good afternoon to all the present here. It is great honor and privilege to propose the vote of thanks on this remarkable occasion. This international conference has been a long cherished dream, and today it is heartening to see come to life. Over the next 2 days, this IEEE conference will serve as a platform for rich discussions, exchange of innovative ideas, meaningful social interactions, of which we hope will contribute towards developing the solutions to the societal challenges. Today my words are not enough to express our gratitude. First and foremost, I would like to thank our distinguished chief guest for today's inaugural function, Dr. Sasi Kumar, Executive Director, CEDAC Mumbai, who has honored this function with his inspirational thoughts. We are grateful for sharing your time and expertise with you, sir. Thank you. And I take this opportunity to thank the guest of honor, Mr. Arun Ashan, Senior Director, Softlink Global, Mumbai, for taking out time from his schedule and sharing his words of wisdom. Thank you, sir. Our sincere thanks to IEEE Bombay section for their unwavering support and recognition. I express my honest gratitude to our President, SIS, Dr. V. Shankar, and Vice President, Shri M. V. Ramnarayan, for their constant support. I express sincere thanks to Honorary Advisor, Dr. P. V. Parmeshwaran, sir, for his valuable guidance and continuous support. Thanks to the Advisory Committee and Technical Program Committee for their time-to-time guidance and support. I take this opportunity to express thanks to our principal for enthusiastic support. Thank you, ma'am. All the hard work, timely management, sharp organizational skills demonstrated by the team led by the chair, Dr. Preeti Hemnani, along with the co-chairs, Professor Biju Balakrishnan and Professor Suvarna Chaudhary, has resulted in overwhelming response from the research and academic community. On behalf of organizing team, I extend our heartfelt gratitude to all the committee who played a pivotal role in shaping and executing this event. Our sincere thanks to Finance and Sponsorship Committee, Technical and Design Committee, Website Publicity and Media Coverage Committee, IEEE Correspondence and Publication Committee, Venue, Hospitality and Accounts Committee, and Registration Committee. Each one of you have worked tirelessly behind the scenes, and your dedication is deeply appreciated. Many thanks to the reviewers and various practitioners invited from the reputed organizations and industry, and my fellow colleagues who accepted our invitation and helped us in selecting the best. Thank you on behalf of the committee. A special note of thanks to our respected registrar for her constant support and encouragement throughout the planning and execution of the stages.
We also express our appreciation to our support staff, both office and non-teaching members of this entire college who have contributed immensely to the smooth functioning of today's event. To our sponsors, thank you for your generous contribution. We are truly grateful for your partnership. Finally, to all the attendees, thank you for taking out time to be here with us. Your participation and engagement have made this event truly memorable. With this, I conclude. Thank you all.
Thank you, ma'am. I request everyone to rise for the national anthem.
शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा